On the night of September 7th, 2025, the world expected nothing more than a lunar eclipse. Instead, the sky betrayed our expectations. As the moon slipped into Earth's shadow, the heavens ignited. An unnatural neon green glow stretched from horizon to horizon. Cameras clicked, telescopes whirred, and within minutes, the ordinary turned historic. What streaked across the night was no local comet, no familiar visitor. It was an interstellar intruder moving faster than anything our solar system had ever seen. Its name, 3I-ATLAS. Fascinated by mysteries like this? Make sure to subscribe so you won't miss the next cosmic revelation. The lunar eclipse should have ended in silence and darkness. Instead, the world gasped. From Cape Town to São Paulo, the night exploded into a glowing emerald haze that clung stubbornly to the sky even after the moon slid free of Earth's shadow. Amateur stargazers scrambled to steady their tripods, capturing the surreal shift, a comet streaking icy blue before transforming, impossibly, into a saturated green that refused to fade. It wasn't just unusual, it was unprecedented. No comet in living memory had ever painted the heavens this way. The glow lingered like an alien signature, daring anyone to explain it. The earliest images came from backyards and rooftops. In Buenos Aires, a telescope operator caught the first shimmering traces against the darkened moon. In Nairobi, a hobbyist posted raw frames of a pale blue streak intensifying into green. And in Lisbon, an amateur group stacked exposures that revealed the same story. Whatever this was, it was moving fast and glowing in a way that defied every handbook. In São Paulo, a student with nothing more than a borrowed DSLR caught the transition in a burst of 10-second shots. Each frame showed the shift from icy blue to deep green, perfectly time-stamped at 3:18 UTC. By the time those images hit astronomy forums, the chatter had erupted into chaos. Something was wrong. Something was new, and it wasn't from here. As the green glow stretched unnaturally across the night, the internet lit up just as fast. Astronomy forums, usually sleepy corners of niche debate, exploded into a frenzy of uploads. Stacked images, raw frames, coordinates, exposure times, and filter data poured in from every continent. A retired engineer in Cape Town logged the object's angular movement through a 6-inch Newtonian, his notes showing a speed so rapid that even minutes apart, the streak had clearly shifted against the starfield. In rural Turkey, a teacher posted a time-lapse capturing the exact moment the comet's icy blue dissolved into glowing green. And in Morocco, a high school astronomy club measured its displacement with startling precision, confirming what many feared. This visitor was moving too fast to belong here. The numbers were brutal. Its apparent motion approached 1/4 degree per hour, far beyond the behavior of any known comet or asteroid in the solar system. It was as if the night sky itself couldn't hold it still. Amateur networks are rarely quick to agree. Disputes over filters, calibration errors, and observational noise can last for weeks. But by dawn, the data spoke louder than debate. From São Paulo to Lisbon, from Nairobi to Ankara, one conclusion began to crystallize. This was no ordinary solar system object. The professionals were still silent. The official channels were still waiting. But the amateurs had already made the call. This was an interstellar intruder. By the early hours of July 1st, 2025, the Atlas Survey Network had its say. Inside the control room, analysts ran the object through orbit solvers, checking against catalogs of known asteroids. The algorithms should have locked onto a neat ellipse, something bound to the sun, something ordinary. Instead, every attempt spat out chaos. Residuals climbed with each adjustment. The numbers refused to settle. The data screamed one thing. This orbit didn't close. Eccentricity greater than 1. Hyperbolic. The signature of an object unbound to the sun, crossing through the solar system on a one-time trajectory. The team hesitated. False alarms waste time, burn credibility, and clog the Minor Planet Center with noise. But the log entry at 3:14 UTC captured the tension. If this is real, it's interstellar. If not, we're about to waste the world's time. At 0512 UTC, the decision was made. The alert went out. Orbit fitting failed. Eccentricity above 1. Outbound velocity unbound. Within hours, the Minor Planet Center stamped a designation on the object, 3I-ATLAS. It became only the third confirmed interstellar visitor in human history, following the infamous Oumuamua in 2017 and Borisov in 2019. But this one was different. This one burned emerald, and this one was moving faster than any probe humanity had ever launched. From the moment Atlas confirmed its hyperbolic orbit, one truth sank in. 3I-ATLAS was untouchable. At perihelion, it would blaze past the Sun at nearly 98 kilometers per second, fast enough to cross the Earth-Moon distance in just over an hour. No rocket, no solar sail, no probe could hope to chase it down. This was a drive-by, a fleeting guest, and humanity had only a short window to watch before it slipped back into the dark. As telescopes from La Palma to Gemini South locked on, spectrographs began spilling their secrets. Everyone expected the familiar signature of diatomic carbon, the C2 swan bands that give most comets their green glow. Instead, the expected peaks at 516 and 563 nanometers were missing. In their place stood something alien, a broad, featureless plateau in the green spectrum. Carbon dioxide outnumbering water vapor 8-to-1, a ratio never seen in any inner solar system comet. Cyanogen and carbonyl sulfide barely registering, too weak to explain the glow. Then came the shocker. Nickel lines, more than 20 of them, sharp and unmistakable. In some frames, nickel outshone iron by a factor of 50. It was chemistry that defied every rulebook. Polarimetry results only deepened the mystery. The dust grains scattering 3I-ATLAS's light showed a negative polarization pattern, something seen mostly in distant trans-Neptunian objects, not local comets. Hubble images hinted at a compact nucleus just a few kilometers across, cloaked in a dense CO2-rich coma. Planetary scientists stared at the data with a mix of awe and frustration. The picture was clear. This was matter forged in the frozen reaches of another star system, a piece of alien planet-building chemistry, now unraveling in our skies. But the clock was merciless. With Earth-based telescopes soon blinded by solar glare, humanity's chance to decode this green intruder was vanishing by the day. By late September 2025, Earth was losing sight of 3I-ATLAS. The comet's trajectory meant the sun's glare would blind even the most powerful telescopes on the planet. The last hope lay millions of kilometers away, Mars. In Washington and Houston, the debate turned fierce. Mars orbiters like MAVEN and the Mars Reconnaissance Orbiter, MRO, were never meant to chase interstellar comets. They were busy tracking climate patterns, mapping terrain, and running long-term campaigns. Shutting down those schedules meant sacrificing years of data, but the stakes were undeniable. Congressional science committees weighed in, demanding priority for the interstellar visitor. Behind closed doors, NASA's Planetary Science Division issued an emergency order: retask the orbiters. Engineers scrambled to rewrite targeting software, negotiate observation slots with European partners, and recalibrate instruments on a clock that ticked louder with every passing hour. In just 48 hours, the decision was forced through, an approval process that normally drags on for weeks. Mars was about to become humanity's only outpost capable of seeing 3I-ATLAS up close. On October 3rd, 2025, the gamble paid off. 3I-ATLAS swept past Mars at a distance of 29 million kilometers. MAVEN and MRO, primed for the encounter, fired off rapid-fire sequences of ultraviolet and infrared observations. For 3 hours, Mars was humanity's eyes. MAVEN returned more spectral data on metal vapor and coma structure than most missions gather in entire seasons. Ultraviolet flashes, infrared signatures, dust scattering patterns, information Earth had already lost to the sun's blinding glare were captured in exquisite detail. It was a triumph pulled from the edge of failure. For one brief window, Mars became the stage for the most important astronomical chase of the decade. Just weeks after the green glow faded, the post-mortem began. Archival data from the Rubin Observatory and NASA's TESS mission revealed a bitter truth. 3I-ATLAS had crossed our skies twice before. In October 2023 and again in June 2024, faint traces of a fast-moving object appeared in raw frames. The signals were real, thin streaks against the starfield, carrying the same unusual color signature. But the detection pipelines dismissed them. The reason reason was painfully simple. Machine learning filters had been trained to ignore outliers. Hyperbolic orbits, flagged as noise, unusual green bursts, marked as calibration errors. In the quest to reduce false alarms, the algorithms had thrown away the very evidence that mattered most. What humanity had treated as static was, in fact, a messenger from another star. The embarrassment galvanized the community. Software teams tore through code, rewriting filters to catch impossible trajectories instead of discarding them. The new mantra, better too many false positives than missing the next interstellar visitor. At the same time, mission designers pushed for something more radical. If algorithms couldn't guarantee early warning, hardware had to be ready to respond at a moment's notice. Proposals filled whiteboards. Rapid response interceptors that could launch within weeks, solar sailcraft designed to ride sunlight into hyperbolic chases, swarms of disposable CubeSats, cheap and modular, able to scatter sensors around an intruder before it vanished into the dark. The lesson was sharp and clear. Watching wasn't enough. Next time, we had to meet the visitor halfway. With 3I-ATLAS fading into the black between stars, the scientific world took stock. Its speed, its impossible chemistry, its glowing green coma, none of it fit the patterns we thought we knew. And yet, that was the gift. Every interstellar visitor carries the fingerprints of worlds we will never see, laboratories of creation scattered across the galaxy. For planetary scientists, 3I-ATLAS wasn't just an oddity. It was proof that planet building, chemistry, and cosmic dust take forms beyond our imagination. It rewrote the rules, and it reminded us how little of the universe we've truly mapped. This time, we were caught off guard. Next time, we cannot afford to be. The lesson of 3I-ATLAS is carved into every new line of code, every new mission concept. Be ready. Interstellar visitors are rare, fleeting, and priceless. The next one might bring answers about life's origins, or questions we don't yet know how to ask. The sky will surprise us again. The only choice is whether we'll be prepared. On October 3rd, 2025, 3I-ATLAS swept past Mars and vanished back into the darkness. It left behind more than data. It left a mandate. Be faster, be smarter, be ready. Its emerald light may have faded, but its legacy burns on. In every telescope pointed skyward, in every algorithm rewritten, and in every mission sketch waiting for funding. 3I-ATLAS reminded us that the cosmos is alive with travelers, and that sometimes the universe itself knocks on our door. If you enjoyed this story and want more deep dives into the mysteries of space, don't forget to subscribe and drop a comment below. What do you think was behind the green glow of 3I-ATLAS?